recording again. All right, so that was I think I'm already doing that, but I'll just do it for fun. Okay, so now there'll be 3 different videos. So they'll be uploaded here as test review, video 1, video 2, and I'll make a whole separate folder here. Actually, I think what I'll do is I'll make an assignment on Canvas, but I'll make a note here. I'll make an assignment on Canvas for that, for turning in the test part. Okay, so that's where that'll be. Okay, so we're on week 6 here, and today we're going to move on. So far what we've covered in ArcGIS is how to use ArcGIS to call existing ArcGIS tools and chain them together. So I've got tool number 1, and I can chain tool number 1 to tool number 2, and tool number 3 to tool number 4. I can chain tools together and call multiple tools. That's really valuable because I can automate a particular task. If my task always involves running 5 different tools, I can do that. Now, Model Builder does the same thing. That's what Model Builder does, and we kind of reviewed how you can even take a model and export it to Python now in the newest version, and the newest version should be on your computers. So that's great. But there are cases where you want to get into the GIS data and ask questions about the GIS data and manipulate the GIS data in new ways. And so, first of all, we need to talk about what is GIS data. We're going to spend, there's actually 2, maybe even 3-ish, depending on how you look at it, but we're going to spend 2 weeks on this. And so, today we're going to talk about just, when I say data, we're going to talk about just part of the data, and that is manipulating the attribute information of a data set. And then next week we'll talk about manipulating the other data, and then we'll move on to the points, lines, and polygons. And then we'll move on to raster. With raster, it's kind of blurred, right? Like, it doesn't fit into this neat category. So with vector data, though, there's 2 sets of data, right? There's the where information, where is it, and that is the geometry. In fact, ESRI calls those things geometry, and that's the stuff we're going to get into more next week. But let's think about what that is. So we have points that exist in space, or lines, or polygons. You notice how every layer is either points, lines, or polygons, right? So a point is just a coordinate, and a line is a series of coordinates. Now, what is a polygon? The way it's treated. Like, let's think about if we wanted to represent the state of Hawaii. I think I've done this in another class.
It looks like shapefile, but is it more easy to manipulate objects than, like you said, raster points and those objects are, right?
Yeah. So we'll get into actually manipulating them later, but
It's a combo of points and lines.
yeah, it's a combo of points.
The area contained within certain.
Yeah, so it's a series of points, and ArcGIS, and we'll break this up, but it's important to know that a polygon isn't a single polygon. In other words, a feature, a row in an attribute table has a feature associated with it, right? Like it has some geometry associated with that. And the geometry might be an individual point. We call that a point. It can actually be, this is not as common, but it does happen. You can have a single row in an attribute table that actually represents a bunch of points. They call that a multi-point. Sometimes LiDAR data, anybody know what LiDAR data is? Okay. Yeah. Sometimes LiDAR data, if it's delivered in a shapefile or a geodatabase format, is delivered as multi-points. In other words, there's there's a row for each for a gridded area, and the row will have all the points stored for a grid. It's not always like that. Sometimes it's actually every single point is a row. Okay, but so there is a multi-point. It's less common. Then there's what's called a polyline, and a polyline can represent one single line, or it could represent multiple lines. So one row can have multiple lines, and one polygon can have multiple, what they call rings. A ring is a series of points that starts in one place and ends back in that same place. So one polygon can have multiple rings. And
so what's the difference between a polygon and a shapefile? A shapefile, is
so a polygon is, what I'm talking about is one element in a shapefile. And also a shapefile is a file format, so it could also be a geodatabase, right? So if I open up ArcGIS Pro here, and I have this project that I've worked on. By the way, I have some data, but it wouldn't let me upload it to GitHub. It's too big, so I'm gonna put it on Canvas here real quick. I just remembered I forgot to do that. But well, this is coming up here. So these are all the congressional districts in the United States. I was working on a problem for this take-home portion. I thought of using the congressional districts, but I think I don't think I'm gonna do that for the take-home portion. I'm gonna do that for next week's lecture. But anyway, if I select one of these guys right here, that is a polygon. That's one polygon. If I open up the congressional districts one for the 110th Congress here, see how it says the shape is a polygon? And most of the time, those polygons, for congressional districts at least, are going to be single polygons. So if I zoom in here, well, that's a weird shaped congressional district, right? So that congressional district is one single polygon, even though it's a weird polygon. But I'll bet if I sort this, there are some, like I pointed out Hawaii before, A, B, C, D, F, G. So looks like there's 3 congressional districts in Hawaii, but I'll bet all of them contain multiple actual polygons. So here's one. That one looks like it's just part of Oahu, the island with the most population, not the big island. And actually, it looks like there's only 2. So the other one is everything else. So you see how there's 1, 2, 3, 4, 5, 6, 7, 8 polygons. So that polygon represents, that what's stored right here. No, I guess I need to get up. What's stored in here is actually 4 rings, or 5, or however many I said. 1, 2, 3, 4, 5, 6, 7, 8. 8 rings are stored in there. Okay? And we're actually going to put off getting this information, talking about this information and how it's organized until next week. But I just wanted to make you aware that this attribute table does have a column that represents the shape, and that shape that's in there, you can get that out. And I'll show you how to get it out this week, but then we'll talk about what to do with it. We'll talk about what we can do with it next week. Not next week, in 2 weeks, next time we meet. So points, lines, and polygons. Okay. Points, lines, and polygons. And then the table data. And they're linked together through this attribute table. Okay. But you can think of that information as actually being stored there. So we've got rows that represent all of our features and columns that represent all of our attributes. And with vector GIS data, you can think of the where information, that geometry information, as one of the rows in our data set. Okay. All right, and they're linked together. Okay, raster data, we're gonna kind of leave that behind, leave that because in raster data we don't actually store anything about the points, lines, or polygons. We don't store any where information other than we just drape this thing on the Earth, and because the cell size is implied, the location of every raster cell can be inferred. Right? But it's just rows and columns of data. All right. So let's say we want to get in here and we want to access the information that's in this attribute table, and we want to do something with it. Okay. We want to change something. Well, first of all, what if we wanted to add a new field and calculate values into that field? We don't need to use Python for that. How would we do that without Python?
You add field, like
Just add a field and then the field.
calculate field.
Right.
Right click and calculate.
Now, we could definitely do that. But what if what we wanted to do when we added the new field, what if we wanted to make some really complicated method to determine what was in the new field? In other words, we wanted to reclassify things. So the example that I'm coming up with right now is actually taken from another class. So let me get the data up here. I'm just going to say new project. So I'm going to call this week. What is this? Week 6. SPA, and then I'll save this. I think I can save this in C temp, or no, C. It's users. I'm trying to find my directory. Users, George, courses, SPA, week 6, and then I'm just going to call this project, and then I'll put this right here. That's where I want to put it. Okay. Save changes to project 1. I don't need to do that. Okay, so if you want to follow along, what I'm going to do here is I'm going to, so this is my new project. I'm going to put a new map on here. What I'm going to do is upload the data, which actually is the exact same data that was used in Lab 3 with the tornadoes of my other course. So if you already have that, you can just get that there, but I am going to put it up in this class. The other course I teach this semester.
417.
Yeah, 417. But I'm just going to upload it here. So I'm going to go to Files and Upload. So there doesn't look like there's any other files uploaded. So right now I'll just put it right in Files, and it's going to be C. It's just as GitHub doesn't allow things that are over 100 megabytes, so it's a little bit big. I should have just made it smaller, but I didn't realize it wasn't going to upload until this morning. So I guess I have to actually hit upload. Or is this? Nope. I should just make it smaller. Come on. Does that mean that it's going to take this long? Hold on here. I think what I'm going to do, add data, C, temp, ex data, okay. Tornadoes, control, US counties. U.S. counties, geoprocessing, select. I'm going to do what I said I was going to do. Make it a little bit smaller here real quick. Okay. So I'm gonna select out. Did it upload yet?
What week was that?
Week 3.
Week 3?
Yep. So databases, EX data, tornadoes. So I'm going to change this so that year is greater than or equal to 1980. Actually, I'll go 1970. I think that'll still work. All right. Yep. Remove that. I didn't mean to call that. Okay. So now I'm going to delete. Yeah. Okay. Rename. All right. And save. There we go. X that out. And see users, George, courses, SPA, 6, archive, oops, project, SPA. I didn't change the projection, but when you add,
Oh, the data was already projected.
exactly. Okay. So copy. All right. Paste. The data will be there in a second. Okay. Let's see if it made it. What's that?
It's there on the GitHub.
Awesome. Okay, so now under M6, you could see that the data is right here. You can download that data, and it's just going to have the counties and the counties and the tornadoes since 1970. So it's a lot smaller. The other one had a ton of other data that I'm actually didn't even plan to use, but I thought it'd be easier to reuse that. So I'm going to add those two data sets. And if you're using the one from the actual lab that's not since 1980, it's not a big deal. Okay, so I've got both of my data sets there, my tornadoes and my U.S. Counties. Okay. All right, so I'm going to look at the tornadoes attribute table, and I can see that there's a bunch of information here, right, in the attribute table. And if I want to get some information from this attribute table programmatically, I need to use what's called the data access module. So remember we talked about what modules are. So this is a module that's part of ArcPy. So technically it's a submodule. And I need to use the data access module to access data, vector data. So vector data, you use the data access model to get to it. We're going to use a different module to access raster data. But if I want to get any of this data, I'm using that data access module. In my corrected version, I have the link to this, but it's really easy. You do ArcPy, ArcGIS Pro Data Access Module. So this is the main help page for the data access module in ArcGIS Pro. And you can see that the data access module, you get to it by importing arcpy.da. That's how you access the data access module. And remember, a module, what is a module?
It's a group of program instructions to do a particular function.
Yeah, exactly. So it's a program. They're actually not always written in Python, because you can actually write a function that Python can use in C, so or C++. So sometimes you can't access the code itself, but it's still written for Python. So I don't know for sure. I don't know if you can open up the Python module and look at the Python code for it. But what this page is telling you is that these are the functions that are available to you inside of the data access module. So you can do some of these. We've already actually talked about describe a bit earlier, but the describe function returns a list with a bunch of properties. So you can find out what all the fields are and things like that. So we could demonstrate that again, but we did kind of discuss that a bit. Then we'll talk about some of these others in a second. Okay. But what I really want to talk about are these data access classes, particularly these three: the search cursor, the insert cursor, and the update cursor. Those are the most commonly used data access classes. And what they allow you to do is to get the table as if the table itself is a sequence. So what do you think that the items in the sequence represent in a table? Like, how would you break up a table and say, I want to look at your items? What do you think those items would be?
Right.
Exactly. So you can use these cursors, and what the cursors do is they give you the cursor becomes your table, and the items in that cursor are the rows in the table. So if you create a insert cursor or a search cursor, if you create a search cursor or an update cursor, what it does is it gives you something you can iterate over. You can say for row, you can actually call it row. It's a variable. You can call it whatever you want, but it makes sense to call it a row. For row inside my cursor, and then every time it'll actually just run a loop, and every time you run the loop, you're inside the loop, row will be the next item, then the next item, then the next item, then the next item, then the next item, the next row in your table. So that's what they're useful for.
So those it's running. I don't know if this got anything to do with arrays, but it's gonna run through every row in the table until you tell it to stop.
Yeah, you can either tell it to stop or it reaches the last one. So you could say, okay, I want to go through every item, and I want to, when I get to the end, stop, or I reach some criteria, I could just tell it to stop. Okay. So do you remember how to break out of a for loop? So there's two different ways. One's called break, one's called continue. So break will completely break you out of the loop, and it'll stop execution of the loop. If you do continue, it will stop any other code in that loop. It'll stop, but it'll still try to do the next loop. So it'll say, oh, you know, like let's say you want to encountered a value and you want to check the value, and if the value is something, you want to do something to it. If the value isn't something you want to do, you want to just say, okay, forget it, give me the next one. Then you use continue. But you use break to say, okay, I've done everything I want to do in this loop. go on to beyond the loop.
Okay, so if a condition is true, break.
Yeah, if you wanted to stop the loop.
Right.
Yep, exactly. Okay, so we're going to practice first with search cursor. So search cursor establishes, see this word, read-only access to the records returned from a feature class or table. The records are another way to say the rows. Okay, some people call those rows. What do you think it means by read-only access? Yes, that means that you can't change the value. So it's giving you this table, and you can go through it row by row, but you cannot change the values. Okay, that's what it means to be. That's what a search cursor is. So you can use a search cursor to inspect the values, and you could calculate the mean of all of the values in a table. You could use it to make a report of a table for some reason. Okay, you could do all sorts of things like that with the with the search cursor. But you couldn't actually update anything. So if you want to do something like we talked about before, if you wanted to create with the search cursor, if you wanted to do something like we did before, where we want to create a new field and calculate the values in a new field, you'd have to do that with the update cursor. But before we get to there, let's practice. Let's use the search cursor for something. So they've got some examples here. This is how you create a search cursor. It requires that you give it the name of a table, the path to a table, or if you're executing in Python itself, you could give it just the name of the table. Now it says table, okay, but notice in the help it says the feature class, layer, table, or table view. In other words, anything that can be reasonably assumed to be a table can be thought of as a table. So it can be a representation of a shapefile in ArcGIS Pro, or a geodatabase. Anything that has a table associated with it. In fact, including a raster with a table. Do you guys know what situations a raster might have a table associated with it? In ArcGIS, the way it treats raster data is that if there are less than, I forget the exact number, but it's in like somewhere between 30 and 50. If there are less than 30 or 50 unique values, it automatically will create a raster table. And that raster table will contain all the values in the raster and another column called count, which will be the number of values that particular, in other words, if it says 1 and then it has the value is 1 and the count is 786, that means that there's 786 cells in that raster that have the value of 1. Okay, so you might need to programmatically get to that information, but we're not talking about rasters right now. But really, anytime there's a table associated with a data set, you can get to it by using this. It doesn't have to be what ArcGIS calls a standalone table. Anything. Okay, so it's gonna get that. Now,
with that feature class will be the output field that you put in that feature class, and within that particular item that you named, you can get the field name and all that other stuff. It's like going to attribute table.
You give it the path to the table or the name of the table if you're accessing it right in ArcGIS.
Okay.
Yep. And then you need to give it the field names. What
you're looking for.
What's that?
What you're looking for. The field name is going to be
right. So you don't actually have to get the whole table. You could just get part of the table if you only cared about part of the table. So in other words, if I only cared about 2 columns, I could just specify those 2 columns. Or, like it says here, I could use an asterisk instead of a list of fields if you wanted access to all fields. So let's start with that by default. So if you wanted everything, you just hit you just put an asterisk in for this variable. Okay. And then the rest of it is optional, but basically what they allow you to do is to input a where clause. What's a where clause? Like you've seen that in other places, right? Like the select tool I just ran asked for a where clause. And what was it useful for?
certain things on them.
Yes. So if you put in a where clause, in other words, if you say where tornadoes or where year is greater than 1970, then it's going to actually only return the table that you're going to be looking at in your search cursor is only going to be a subset of the data. So you don't have to take the entire data set if you don't want the entire data set. Okay. That's what.
Is that like a filter?
It is. It's kind of like a filter. Yep. It's filtering out only the records that you want to see.
So did you say when it would be preferable to do this rather than just doing a part? Like when would be a situation when you'd actually just want to code and add a row that way?
Well, anytime that you want to like automate a task, like in other words, if you want to just be able to create a task and have it run unsupervised, like so if it's something that's going to happen every day and you want to not touch it, you just want to press the Python tool and have it run.
Like a task that would require that.
Right.
Maybe I'm
So another instance is if the function for doing so is more complicated than that might require like 7 or 8 different select statements. Because you could actually just run the same code. You could actually just write a function that did what you wanted to do. So in my other class, we have this magnitude field right here, right? And it's got -9s and it's got 0s. And the -9s for magnitude. Magnitude is the EF scale of the tornado. Okay. So -9 means we have no idea what it was. Okay. And 0 actually means that it was I forgot exactly. I think 0 means that it was like unmeasured or unknown. I guess -9 and 0 almost mean the same thing. And then magnitude is the EF scale. So as part of this class, we wanted to change the weight of the magnitude. We wanted to double it, and then we wanted to make all of the number 1s. I'm sorry, the number 0s and the number 9s. We wanted to make those. We wanted to make those all 1. So in other words, the rule was if it's less than 1, make it a 1, and if it's greater than 1, double it. Okay. So if we had a situation like that, we could do that without coding, but that would require 3 select statements and then 3 different calculate value field, 3 different calculate values. Okay. So it would help to just be able to write that function in Python. And in fact, ArcGIS added that ability into calculate field. So the first thing that I want to do is to add a new field to this to take our new value for our example. So
Like that particular function, you came in every day and just turn it on. You don't want to go through the same sequence to do it again. You want it automatically take the same information and just run like you were just saying. You don't want to go through all the sequence. If that clause is already in there, it's going to automatically do everything you're saying without wasting your time and updating.
Right. You don't have to press 7 buttons.
Right.
Yeah. Yeah. And like another lab that I've been working on that I'll try to get in here is like, okay, so here's some earthquake data, or sorry, earthquake, USGS, GeoJSON. So, like, here's all the earthquakes that happened in the last day through all the world. So if you could write a script that would take this data and then import it in ArcGIS every day, you could you can analyze it, or there's lots of sites out there that have data that's served up every day.
So that would let you pull that information each day and then create a map for all that information on the daily without having to sit down and write it all out every day.
Right, and that's basically what USGS is doing. And places like this, that's what they're doing. They're pulling those down and putting it on a map. All right. Okay, so so if I wanted to do arcpy.add field, I'm doing this right in ArcGIS. Oops, it's add f. That's not big enough, is it?
No, it's pretty hard to see.
Okay. What did I do last time? Oh yeah. Yeah. Let's do that. I had to get here. Per display settings.
Do you do a where clause on the data that's going to change more frequently, or just anything associated with change?
This is what I changed, right?
Well, is there a reason why the reason why you would do it because the data that change more frequently is that what you put the where clause on? Is it just for changing data like that?
Well, it allows you to basically say I'm only going to change this part of the data, so, or I'm only going to calculate on this part of the data. Okay. So now this looks horrible, but I'll get rid of this. Okay. ArcPy dot add field parenthesis, and I want to add a field to the tornadoes. I got to put it in quotes. Tornadoes since underscore 1970. It's not helping me. I got to find out what I'm doing wrong here. Add field. In table. That's right. Let's look at the example here. Well, this should work. Oh, it's management. That's the problem. Yeah, there we go. There we go. The Python window is under analysis.
See, I was showing a way to add fields through like all the clauses and equal, less than, like all the steps you go through in ArcMap.
Yeah.
I've never done so much work.
Yeah, so there's you can add a field in 3 different ways in ArcMap. One is to press this little button right here, right?
Yeah.
And you can do anything you can do in the GUI, you can actually do in the Python window. And then the third way is through geoprocessing. You can go to add field. And this is actually just running the geoprocessing tool. So my field name is going to be I'm going to call this magnitude, and then it's going to ask for the field type, and the field type is going to be, oh look, it's prompting me here. I could say I want it to be a long, and then everything else I'm going to leave it default. So I'm going to put a parenthesis. So now this Python line, I could run this in IDLE, I could run this in Jupyter Notebooks, I could run it anywhere. But if I ran it in IDLE or Jupyter Notebooks, I'd have to give the full path to this field. And if I had it open in ArcPy, it wouldn't let me do it because it would say, hey, it's being edited by another user. So now I run it, and when I do that, I get this field called magnitude over here.
It's 2 enter, right? To run it on this one.
It shouldn't be. What's the message say that you get? Did it work for you? Did it work for you, Elvis?
So I'm just looking because I'm on these.
Work for you.
1970.
Yeah, mine.
Tornadoes, yeah.
Yeah, I mean, it depends on what it's called. Yours
Oh,
is called
tornadoes?
tornadoes.
Okay.
Yeah, so you just call them.
Tornadoes. I called mine tornadoes. And
Just regular tornadoes and tornadoes since 1970.
I made mine.
Renamed.
I made mine tornado since 1970 because I just wanted it to be a smaller data set. But if you have the full data set, that's totally fine. You just need to make sure just call it tornadoes. And it just, I think I spelled tornadoes wrong. Like you should make sure that it's spelled without the. It should prompt you. Yeah, hit enter. Yes.
Okay, yeah, it works now. That's what it was.
I did mine as tornadoes. And then
This big. This is moving. Yeah. So just. Oh no! Wait. You're right. You're right. I'm sorry. Okay, never mind. It's not a big one. Okay. Now press. Start typing. Quote. T.
management.
Doesn't show
Is that
up.
not the way you spell tornadoes?
That is the way you spell tornadoes, but I think I might have spelled it wrong. Like you need to make sure it's called that in your map catalog because I think I spelled it wrong.
That's okay. That's how you spell it. That looks right though.
I don't know.
I don't know.
It's like potato, and
ring it is.
do you put an E on the end of potato? That's like what Dan Quayle did that a long time ago
Or tomato.
before you guys were around.
Yeah, I was okay at spelling up until I learned what spell check was, and then that went out for me.
I never remember doing spelling. I was never hooked on phonics.
Yeah.
Yeah. So this added that new field called magnitude. Yeah. All right. And now the reason I did that was for later because I'm actually going to open this first as a search cursor. And if I do it as a search cursor, then I'm not going to be able to add anything into that field anyway. Right? So let's do the search cursor. So here is the here's the line. Oh, here we'll get a line like this. So there are a few different ways to do it, a few different syntax. Actually, I'm just going to type it in. I'm going to type it in the way I want to type it in first. arcpy.da. So it's in the submodule DA. If you import, like if I said import arcpy.da, then I could just say, da dot. But I haven't done that. ArcPy is automatically imported at the Python window, so it's already there. arcpy.da.search cursor. I can just press enter to get anything that's prompted. And then notice that the prompt now is telling me, okay, these are the two fields you have. So if I get tornadoes since 1970, I can click on that. And then comma. And then it's going to ask for field names. The default is star, which means I want everything. And you do have to put that star in quotes. I think the help should be more clear about that. Now, if I do this, I'm all set, but this is actually a function. How do I know that's a function? Yeah, so arcpy.da.search cursor it's inside the arcpy.da module, but it's a function, and look at what it's going to return. It's going to return a DA search cursor. So it's going to return something. So I have to set something equal to on this side in order to get it, to receive it. If I just press, in fact, you don't have to do this, but if I just press enter right now, because it's Python, it's going to tell me, oh, you got a search cursor, but I never grabbed it. I didn't assign it a variable name. So now I can't do anything with it. So if I want to get it, I actually have to, if I want to hold it and do something with it, I have to say, I could call it, I'm just going to call it rows because it's kind of like a bunch of rows. Or I could call it a table. I'll call it rows. So now I have the value of that DA search cursor inside of rows. I told you that search cursor was a sequence, but it's a special thing. It's an ArcGIS thing in reality. But I can index it using the for statement. I can say for whatever in whatever. But I don't even know if I can do this for sure, but let's see if I can index it like other sequences, because Python is usually pretty forgiving, and if it understands what you're trying to do, sometimes it works. So it would be Pythonic to be able to say, I want the third row in that table. So, or actually that'd be the fourth row, right? So rows, bracket, 3. I don't even know if this will work, but I'm going to try it. So it says that that's not going to work.
So what did the one right before that do? The rows equals?
That assigned the search cursor to rows. Okay. So rows is a search cursor. So we know that usually we can access items in in a sequence by doing this, but ArcGIS isn't allowing us to do that. So we need to go learn more about what a search cursor is and how to get its items. Well, here is the
So is the object of the function, which is DA search,
sorry, this right here.
variable is rows then? Will rows be the variable?
Rows is the name of the variable, and that variable is holding our search cursor. Okay. It's holding it for us. Like.
So rows just became a copy of ArcDA, search cursor, tornadoes, all that information. So now anywhere you put in rows, it becomes that function that it's saying.
Yep. So we can do something like print. Not print. I'm going to say for row in rows. So what I'm doing is I'm trying to get all of the. I'm creating a loop of all the rows, and every time through the loop, the individual row will be called row. Okay. And I do have to put a colon there.
So it's not in the magnitude function. Will it come back with an error, or it will come back with something? That's just one of the variables. I see it's null in there. So does that stop that function from delivering what you're trying to do?
What's that? Ask that again.
You see what the magnitude is, which is the fourth field. So were you asking it to return something in that row? Were you asking it to return something? The reason why you came back with that error?
Oh, right here?
Right.
No. This was just, I was just doing an experiment. I was trying to see if I could get the fourth row.
Right.
And that syntax doesn't work.
Okay, because that's a list you was actually.
Well, it's a list or tuple. You'd access them all that way.
Okay.
Yeah. So I'm going to say for row and rows. I press enter after the colon, and it'll actually prompt me. So if I want to print row, then I can do that. So now it's going to print the row. What's interesting is that now I'm going to double tap, and it's printing every row in that tornadoes data set. It might take a really long time. Print row. Print parenthesis row parenthesis. But you see how this contains all the information? See, like, you could see I get the first thing here, right here. That's the object ID. This is an X and a Y value. The next value is the FID, and then the OM, the year, the month, the date, and so on. So I don't know what OM represents. So the one that's printed right here should be the very last one. But I'm not going to go all the way down to the bottom. Okay. You actually can specify that you want to change the order on your. So if I go up here, this field precision, field type, field scale. No, oh no, add field. Yeah, search cursor. Look at one of the other. Got the where clause. Nope, there's no order by. I thought there was an order by clause. There isn't, but that'd be cool if you could. Oh, SQL clause. Let's see what that does. Search cursor. SQL clause. A postfix clause. Yeah, so you can do an order by. An SQL, let's see, an optional pair of SQL prefix and postfix clauses in a list or tuple. So if you really wanted to, I'm going to change mine so it says rows equals, and then where clause, none. Spell to points, false. Oh, spatial reference, none. Where clause, false. SQL clause. Order by here. I don't even know if this is the right syntax. I probably shouldn't be. Yeah. Okay. All right. Well.
So you're trying to get the order of printout?
Yeah. Well, the table can be arranged however you want it to be.
Okay.
Just like you can sort the table here. What it's doing is sorting the table for you inside of that. All right.
There's no order to that start thing. You're just gonna split out everything.
Which store thing?
You know what that star in the
Oh,
middle?
the star part is the number of fields. All right, this is getting kind of cramped in here, and so one thing I want to do is run this. Since this is a search cursor, we can run it outside of Python. So if you one of the things that I added, that's not what I meant to do. One of the things that I added to the computers when I updated it is the ability to create to be able to go to IDLE. Let's see, it's not working. No, okay. It didn't install it as an item, but if you go to where Python is installed on your local system, isn't it like this?
Where Python is installed?
Yeah, where's Python installed?
Up. You're going out there.
Sorry, what?
Is that you had the top? You didn't like that. There you go.
No.
3 or 4 down. Right? Is IPython, is that where it's at?
That's not.
It's under the.
I think it's C. Let me see if this is it.
Folder.
What's that?
It's under the ArcGIS folder too. Like you go to start menu, ArcGIS.
Oh, okay, it is under there.
Yeah.
Start
Oh, not right there. There and then ArcGIS.
ArcGIS.
Scroll down and then.
I don't see it.
It's on mine. Let's see.
I do know that you can always get to it by. This is kind of a clunky way to get to it, but let's say I wanted to create a script right here. Well, I've got a script right there already, but let's create a new file, a new text document, just a plain text document, and then I'm going to rename this test.py. I'm going to call this search cursor.py. Search cursor.py. Yeah, I want to change it. So now it's a Python file. It's an empty Python file. I right-click it, and I tested this on a few of the computers, so you should see this now if you right-click. Edit with IDLE parenthesis ArcGIS Pro. That's the one that'll open up this window. Anybody else get that? Did that work on anybody else's machine? Okay.
I ended up with a different one. Let me see.
It might be white. It might be that I've made this darker.
Well, it was pulling a 2 point something vertical on mine, so let's see.
Okay. Well, let me find the path now. I can go into ArcGIS and I can get the full path to this thing by right-clicking on it and saying properties. And if I go to source, here's the full path to that data. And I like to put the little R in front just in case. Now this is really long because the path is long, so you'll just have to remember that it has this extra. So, what's that?
The search cursor.py.
I just created a new file called searchcursor.py. Here, I'll show that
And
again.
it automatically made it
I right click and say new text document. You have to make sure that you delete the txt part too. So up here under view, you might have to say file name extensions. You might have that checked. See, if you don't have that checked, it'll look like that, and it won't ever let you change the txt. But if you go to view and you say I want to see my file name extensions, then you'll be able to say, okay, that's search cursor. I'll call this 2.py, and then it'll say yeah, and then now I could right click on that and edit it in IDLE. I don't know why.
IDLE with ArcGIS Pro or
Yes.
myself?
No, IDLE with ArcGIS Pro. Otherwise, it's running Python 2, which it'll probably still run in most cases, but not every case, and definitely if your print statements won't work. But it's the one that installed with ArcMap. I don't even have ArcMap on this computer though, so that's why I don't see that.
And you said you just had to copy the location.
Yeah. So here's my rows equals arcpy.da search cursor, and then all this information.
It's in the property, right?
What's that?
The properties to find the location.
Yeah, to find the location. All right. So the reason that I'm doing this is now I can say for row in rows and print row, and it's not quite as crowded. So that's what we've done so far up to this point. If I run that, it's going to get me. It's going to do the same thing. Oh, ArcPy. So I have to import ArcPy because if you're not running it in ArcGIS, you have to specifically say it. So, yep. That's all the rows. Okay. If I only want to see one of the items in that row, now these are actually. Can you see what these are? I mean, they're going really fast. But what's that?
Like grid coordinates.
Well, they kind of look like grid coordinates, but what data type is one of these? We'll look what it starts with. Yeah. So each row is actually a tuple. So if I only wanted to get the 5th row, I could just do that. By the way, if I restart anything, it'll restart it for me. So now I'm just getting the 6th row because it's 0 indexed. Okay. I mean, I don't know what the 6th row is. We can go back to ArcGIS and find that out.
So if we were able to open the IDL
So it's the month.
IDLE, like the GUI, like we wouldn't have to import ArcPy, right?
If we do it right from Python,
We'll do it from the what you were trying to find first, the IDLE
no.
Python GUI.
Anytime you open up IDLE, you have to import it.
Okay, even if it's underneath the ArcGIS
Yes.
stuff? Okay.
Yep.
So in this program, you want to alter the program in ArcGIS from outside of ArcGIS. You can actually
Right.
create a layer.
Any of the Python tools run outside of ArcGIS. They run in Jupyter Notebooks. They run in IDLE, which you didn't have on your computers until they didn't. IDLE didn't install until 2.3, I think. So now you have it on your computers. The advantage to IDLE is you can just write a script and run it. Like in Jupyter, you can open that thing up. It works great for interactive stuff, but it's it's a little clunky if you just want to write. If you wanted to write a script that ran every day, that example that I had before, you could write it in Jupyter to start off with, but then you'd want to export it and just run it. Eventually, you probably just want to run it at a command line.
Well, do you have to have ArcGIS open if you're doing both so you can see see if it went right and you didn't run correctly?
Well, if it has print statements. See, I could, one reason why this is taking so long to run is not because there's so many records. Like if I just, said A equals 5 here and ran this, and then actually print done. It takes a long time to print these things. Surprisingly long amount of time. So now I've got this, this that's just going to, I'm running, and it's still actually going through every record in the table. But look at how fast it finishes. So that print statement caused a lot of time to happen because it actually takes longer to put it on the screen than it does for it to load it into memory. In fact, even if I said A equals row 5, and I ran this, I'm actually assigning A to be the value of 5. However many records there are. Let's see how fast it ran. I just didn't print it on the screen, so it costs time to print something on the screen. So sometimes for debugging purposes you can do a print statement, but you want to take them out when you actually ran. Okay.
Quick question: where when you're copying the location, are you copying the location of the whole map, like to do the search cursor on, or do you have to try to find that actual layer?
This is the name of this is the path to a layer.
Okay, so it's within.
So it's the tornado since 1970. Now, if I only wanted the month field, that's where I would put. I would change this so that it was just a list of fields or a tuple of fields. It actually doesn't matter. So if I just said MO parenthesis, now I'm only going to get the month. In fact, let's print the whole row. If I do that, I'll go back and watch. This will fail. The reason why it fails is that now there's not a 5th item. Okay. And there's only one item. There's just the tuple. I mean, sorry, there's just one item, and that's the month. See how it's just printing the month? What if I wanted the month and the year? I could just say month, comma, YR. So now it's going to print just the month and the year out. Let's restart it. So it's just giving me those values. All right. So let's say that we wanted to. It's silly to print every single row, right? Let's say we just wanted to get what's a field? Yeah. Let's say we wanted to get the average magnitude but we didn't want to include the negative 9s because the negative 9s mean we didn't know. Okay? So we could do something like this. We could say for row in rows, we could change this so that it's just magnitude. So now we're just getting the magnitude field. So the magnitude is going to be the only field. So how do I access just the value in the magnitude field right here every time through the loop?
When you call statement,
Like a magnitude equals what?
you say the third field.
Magnitude is the only field now, because I said this. If I entered star, if I put star here, it's going to give me everything. If I put mag, it's only going to give me the magnitude field. And if I put comma YR, then it's only going to give me the year field. See that? I mean, sorry, not only the year field. Now it's going to give me the magnitude and the year. And if I say MO, it's going to give me the magnitude, the year, and the month. So now if I run this again, invalid syntax. So how do I get the magnitude though? Each time through the loop, what's the value of row?
So you start with base of 0, correct?
Yeah.
So the first time around, whatever magnitude is. So do you have to put in brackets anything in the number in there?
Yeah, you do.
Bracket 0.
You're right.
That's close. We need to put something before this though.
Okay, so parentheses. So
Can you put rows? Like
Okay.
function?
Rows, remember, is a search cursor.
Oh, okay.
Okay. It's a search cursor, and this is a loop. So every time through the loop, what value gets changed each time through the loop?
the row value.
Right. Row gets changed each time through the loop. And what does it represent?
The row value represents everything that's on that row.
Everything that's on that row, except for we said not everything. We only want these three fields.
Right. So don't you got to name row year and the month? We have to do it the same way you did mag.
Yep. So if we wanted to get those other fields, we could. But right now, if we just want magnitude, we can get magnitude is equal to row 0. Because row 0, what's going to happen is the first time through the loop, row is going to be the first row in the attribute table, but it's only going to be those fields that we specified. So it's going to have year, magnitude, and month is what I specified in that order. So we can change the order of the fields. By default, they'll be in the order that they're in. But if you say magnitude, year, and month, you're saying I want them in this order. So row is always going to be a tuple, but it's going to change. The first time it's going to be the first row. The second time it's going to be the second row. The third row, the fourth row, the fourth row, fifth row, so on. But it's always going to be a tuple. And the first item in that tuple is going to correspond with the first item in this tuple. It's going to be the magnitude.
But don't you have to use parentheses to make it a tuple, or can this be a tuple based on? Don't you have to put them in parentheses?
I did. I put them in parentheses. See how this is in parentheses?
Oh, okay, but I thought down in the column statement.
No, even if it's a tuple, you use this would call a function. If you're saying, like, why don't I do that? Because this would call a function named row. So if I ran this, it would say row's not a function.
Right, okay. But don't you put,
Brackets always mean the item in a sequence.
so but you don't put a parentheses outside the brackets also
Nope.
too, because it's already a tuple. The information you get is tuple.
Yeah. That's how I access the items in a tuple.
Okay.
You access the items in a list, a tuple, and a dictionary, all using those brackets, even though you don't create them that way.
Okay.
All right. So here, magnitude every time through, if I print Watch this, because I don't want to see everything print a million times. So I'm going to say count is equal to count plus count, or sorry, is equal to count plus 1, and then say if count. Do you remember what this operator does?
Link.
Nope.
I see you.
It's not on the test, by the way. But
Model building. I use that. I see you in model building.
yeah, you use it in model builder sometimes. The percent sign is it's called the modulus operator. And so if count divided by 100, it returns the remainder. In other words, so what's going to happen, when is that if statement going to be true? So if count is equal to 50, what's 50 divided by 100? 0, right? 50 doesn't go into 100.
Right.
And what's the remainder going to be? 50, yeah. So 50 equals 0. Is that true or false statement?
Okay.
It's a false statement, right? So is it going to print magnitude?
No.
No. That's exactly right. So what's going to happen is it's going to go into this for statement. It's going to run it. And if it gets to this if statement, it's only going to print this if this is true. What about 100? 100 divided by 100 is 1. With what remainder? 0. So 0 does equal 0, so it'll print it there.
So
You said 100 divided by 100 is 0?
100 divided by 100 is 1, but the remainder is 0.
Oh, okay.
and that's what the parentheses mean, is the remainder, or is that the actual division?
No, this is the remainder. So
Okay.
count. Think of this operator. What it's doing is it's doing division, but it's only returning the remainder,
Okay.
not the actual division.
Okay.
What's the point of that?
So the point of this is that I don't want to. Sorry, I should have explained that better. Oh yeah. The point of this is that I don't want to print every single value anymore. So now I'm only going to print every 100th value. So that's just helping me run it faster. So see, now it finished a lot faster because I was only printing every 100th value. That's what this did.
So that's a good way to like sample. Like if you wanted to
Yeah, if you wanted to
fifth one.
sample every fifth one. If I want to print every fifth value, I'd just do 5. If I want to print every 1,000th value, I'd do that. And it would run a lot faster. See how fast that ran? So I could even print the magnitude and the count. Yeah. So now you'll be able to see that as I run this, the 1,000th value is 0, the 2,000th value is 1, the 3,000th value is 1. I'm just not printing out every single record. Okay.
What is the equal 0 there? I mean, isn't that asking if it's equal to 0?
Exactly. So
What's why though?
right. So so this is doing the remainder, right? That's what I'm telling you. That's what this does. This returns a remainder after division, but it only returns the remainder. So if this is a multiple of 1,000, the remainder will always be 0. So what this is saying is if when I do the division, the record is the record number I'm on. So if I'm on the 1,000th record, after I do the division, the remainder will be 0. If I'm on the 2,000th record, after I do 2,000 divided by 1,000 is 2, with the remainder of 0. So it's asking if you're on exactly the 2,000th record, or exactly the 3,000th record, exactly the 4,000th record.
999, there'd be a remainder.
Yep.
And
So
if it equals 0, so
right,
it wouldn't print.
it wouldn't print.
I see.
So that's how I'm getting just every 1,000th record. And I'm only doing that because it was annoying to print every single record. So I'm doing that, and I'm getting the magnitude and the count. Okay. All right. So what I really wanted to do though was to calculate. I want to calculate the average magnitude, but I don't want the values of -9. So I could say if magnitude is greater than, I also don't want the 0 values. It's greater than 1, then I'm going to say mag total is equal to mag plus mag total. And then instead of printing done now, I'm going to print total, or sorry, mean mag and then say mag total divided by, how do I get the total number? Count. Yeah, I have the count. I have that value already. So now it'll run through and mag total. I have to go like this. Mag total. You always have to remember to initialize your variables. And that will run. So here, I've got every single value. I mean, sorry, not every single value, every thousandths value. But this is actually the average magnitude of all the tornadoes for every single year. Sorry, for every single one. Every single tornado that was in the record, so however many there were more than 41,000 tornadoes since 1970. And this is the average of all tornadoes since 1970.
Is there a way in the ArcGIS Python window to press enter with, like, to make a line instead of it printing? Like, instead of it actually running? Because I was trying to just add in the mag total into the...
Yeah, I mean, you could...
enter, it runs.
You can... Right. You can't do it line by line.
Oh.
But you can enter more than one line in the Python window. So I could put all of this, or a part of this, into the Python window right here. I could paste it all in. See, I pasted everything in?
Yeah.
And then I could press enter, and it would run and give me the result, same result.
So you can't space something out once it's already in.
Right. You can't. Well, you could type it in row by row and press enter, and if you press double enter, it'll run it. Well, okay. If it has a colon in it, it'll let you put more in. But if it doesn't,
okay.
it runs that line as soon as you press enter.
I see.
Okay.
So you gotta edit it over here and then paste it in.
So that is the average. That is calculating the average magnitude of all tornadoes since 1970. Oh. Do you have a question?
Is that a day-by-day basis? It's totaling everything that...
It's all the ones NOAA publishes on their website. It's every single tornado since 1970 because I already subset it out since 1970. Okay. Now, what happens if I wanted to? What happens if I wanted to get? If I wanted to get a report of all of the tornadoes since 1970, but I wanted to do it by year. In other words, I wanted to do 1970, 1971, 1972, 1973, and find out what all of the tornadoes, the average magnitude was, and see if there was a year where one was a lot higher than the other, right? What if I wanted to do that?
First, you want to leave off the month when you're going through, and then you want to with mode, either.
No, I still want the mean. I want the mean, but I want it for every single year.
Parentheses count, like, that's what's skipping, right?
Does parentheses count?
Oh, the whole if statement, if you want it for every year. right?
Yeah, but you said grade.
You mean this one?
Um,
This one's
That's
just a
very
print.
strong.
This is just for printing purposes.
Oh,
Like
okay.
if I comment this line code out, it actually doesn't change anything.
Okay.
I'm getting every single. So this is just gonna plop out the mean magnitude. There, right? Okay. Let's do this. Watch. Okay. So I'm gonna save this file. Save as. I'm gonna call this search cursor. I should put these in the search cursor year. Okay. All right. Now that where clause, remember the where clause? That was after this one. So the where clause would be right here. I could say where year equals the where clauses are sometimes hard to construct, right? So what I'm going to do is go in here and try to run a select statement because this will give me the proper syntax for it. So if I input my tornadoes here and I ask for my expression, I go to change the expression and I type in where YR is equal to 1970. And then I say, I want to make this SQL. Then I can see exactly what I need to type in to Python. So it just says year equals 1970. There's no quotes or anything. So that's what it needs. Let's see if this gives us a different result. So I'm going to try to run that. So there's the magnitude of tornadoes in 1970, the average magnitude of tornadoes where they knew the magnitude. That's the average in 1970. Okay, that's different. It's significantly different than the total average, right? Like, how different are those two? Pretty different. That's almost a 1, whereas this is like 0.4. Okay. So how would I change this to get like 1985? How would I get that?
Year equal to 1985.
Exactly. So I just change this to 85. I run it, and I can now see the tornadoes in 1985. Now that year isn't that much different from the overall average at all. It's actually a little bit lower, but it's almost exactly the same.
So 1970 was an active year.
Yeah, 1970 evidently was a very active year for tornadoes. Well, they were more intense than normal. We could also, if you want to, that might be a good thing to do. We could also just specify the count itself, right? Like, there we go. Actually, to be technical, we should probably put this count equals count plus 1. I would put this down here because we only want to count the tornadoes that actually meet our criteria. In other words, this count is going to be overinflated because we're not even counting some of the tornadoes in our mean. So now let's run it. See if that change. That's probably going to change the values a little bit. Yeah. So now that does. So there was a bunch of those. There's a ton of tornadoes where we didn't know the magnitude. Really small tornadoes. So we just changed that. We got a way different value. So let's see what it is in 1970. Yeah. So actually the difference, there was just a lot more unknown tornadoes in 1970. That's an important thing to know, is that yeah. Let's see what the overall value was. Yours is what?
Okay, mine's saying I got like 4.
Only 4 tornadoes?
Yeah. I must have did something wrong.
So there were 7,694 intense tornadoes. So this number is different. You might also want to print the year. Okay, so what I want to do here, so we know that if we just change this number, we'll get a different year, right? So how could we change this so that we could put all of this in a loop and actually run this multiple times so that we could see how the average intensity of tornadoes changed all the way from 1970 until the current day?
So you want to put a print statement within the loop to
We already have a print statement, so we actually just need to make the loop. Okay. We want to basically run this whole thing multiple times so that every time it prints, we can even create a variable called year. Right? Year equals 1970. Right? So we've got this year 1970, and we could modify this statement slightly. Okay. Remember we used format a little bit last week. So
format. Start at 70 and end up where we're at now.
Yep. So now this is going to format year. Let's make sure this still works. And we're also going to print year mean magnitude in dot format and say year. So let's see if this still works. So what this is doing is, yep, see how it says mean magnitude in 1970 is that value, and it prints the number.
Can you go all the way to the right?
Yeah. This is just, I introduced this a little bit last week. It's just a fancier way of saying year equals space quote plus str year. So what this is doing is, so now we only have to change it once in our code, and it will change there multiple times. So if we change this to 1971 and ran it again, we would get another value. Mean magnitude 1971. It's this. 300, and there were 320 tornadoes. All right, so how do we do that in a loop where we could get the year-by-year values?
Create another thing where it's like year plus 1.
Yeah, year plus 1. Year equals year plus 1 maybe. But where would we put the loop? What needs to be in the loop? Sorry, Jordan, are you saying something? No? Okay. Oh, it was just feedback from me. Sorry. What needs to be in the loop? Is there anything that doesn't need to be in the loop? I mean, this thing pretty much, this seems to do what we wanted to do, right?
Mm-hmm.
So I think
You want to put the for loop, put that outside of the, and then just run it. Each time they go through and add up the numbers, so.
That's awesome. It's like the whole.
I forgot what the last year is, but it actually won't matter too much if we just enter in 2019.
You went to indent region.
Yep. So now, what's year going to be equal to the first time through the loop?
You're gonna be wherever that number was plus.
What's year going to be equal to the first time through the loop?
70.
Yes. And the second time through the loop?
71.
Huh? And then 72. That's what this range returns a list of values that start with this number and end with that, well, into the number before that number. So it's going to return a list of 1970, 1971, 1972, all the way up. So if I run this, it's going to run the search cursor. It's going to run everything all those different times.
Okay, 2017.
So it looks like 2017 is the last year. So see how it died?
Right.
Died in 2017.
Bring your. Oh, might need colon.
So
So I could revise this so that 2017. Was 2017 the last one? So this will be 2018 and it'll run now.
So when you did the for in loop, could you have put a break in there to break it out of, so it won't go to an error?
Well, yeah, I could do that. You're right. So what I did was I just changed it because 2017 was the last year. So if I did this 2018, but let's say I left that at 2019, I probably should. It'd be a miracle, but maybe there's a year in the future because of climate change where no tornadoes happen, right? So what I could do is say right here an if statement, like what you're saying. If count equals 0, or sorry, I could just say does not equal 0, then do this print statement. And I could even write an else statement. No tornadoes in format. Here. Now it's gonna run this. It's gonna run down to here, and then it's gonna get to this no tornadoes in, and if the count is 0. So if there was any years where there wasn't any tornadoes, the error that I got was actually a divide by 0 error. I gotta change this back. Oh, 2008. Does not equal 0. Oh, I didn't write print. Sorry. That's my problem. If you don't print in, if you don't put a print statement in the interpreter, it'll still print it. But if you don't put it in there, so now there's no tornado. It's not that there's no tornadoes. I should actually say no tornado data. And I could even, start in 1930. But since I know the range of my data, I might as well just say 1970 to 2017.
But it's a lot of times you really don't know. You're just searching. And that's probably why you put it in.
Yep. Now, earlier in the course, like Nick pointed out, you could just use the mean function in NumPy. Well, today we're actually going to get into NumPy a little bit, but he's totally right. Like we could, instead of calculating the mean by hand, we would have to do what though? We'd have to put them all into a list and then use NumPy to calculate the mean. I can come back to this example later and show that. So instead of calculating the mean out by hand, we could do that. Okay, and then later in the course we'll talk about using another module called pandas. And why don't you guys see if that works real quick? Because if it doesn't, I need. So Ashley, on your computer, can you go back to here and type in import pandas like that? See, because this is also something they added since 2.2 or 2.3. I don't know for sure.
Pandas and just run it.
Yeah, press enter.
It just said import pandas. That's all it did.
And but it didn't cause an error.
No.
Like if you put import pizza and press enter, you'll get an error, right?
Yeah.
I wish I had a pizza.
Hey, is pizza your favorite food?
No, but I like pizza. I like tacos even better. Okay, so that pandas is actually a library for. I was going to say this in a little while, but pandas is actually a library to do all sorts of data manipulation with tables. And so oftentimes the workflow will be that you take your data and you turn it into an UMPI array, and then you turn that into a pandas data frame is what they call that. So we'll discuss that later. And pandas data frames can do all sorts of things. You can actually do this problem where you could say, okay, well, use this as the condition, and so you can basically create a new data frame where you get the average of one field by another field. So the average tornado magnitude by year. So anyway, but this is just showing you how to get your individual data out if you need it, and what each of the parameters here means. We could have done this a totally different way. Instead of doing a loop here, right? Instead of doing a loop here, we could have, here, I'll just go ahead and show this. Okay, so I got this example, right? So I'm going to say file, save as, search cursor year, dictionary. So I'm going to call this something else, and I'll put all these files in there. Okay. So I'm going to take this all and dedent this region. And then take that out. And now I'm going to take this where clause out. So I'm not getting a where clause. And instead, what I'm going to do is create a dictionary. Here's equals an empty dictionary. And then I'm going to say for year in range. And I'm going to take my years dictionary and I'm going to create a new years dictionary with the year, and it's going to be equal to 0 initially. Actually, I'm going to do this.
I'm going to move your location of rows for the for statement.
Yeah, because year is no longer yeah, I mean, I could do this before the for statement, but I don't have to. So actually, I need to get both the, this is going to be a little bit more complicated, but both the sum and the count.
Creating the dictionary right now, right?
Yep. 0. So it's a dictionary that has dictionaries in it. So see how I have a dictionary here that I'm creating, and the keys for this dictionary are going to be 1970 and 1971, 1972, and then they're going to access another dictionary that's going to have the sum and the count. So what I need to do is say, it's going to say, oh, I need to get the year now, so I'm going to say year is equal to, or I'm just going to say YR is equal to row. How do I get the year? It's going to be which element in the tuple that comes back from row.
Depends on the order, yeah.
Yeah, so what is it going to be?
1.
0, 1. Yep. So it'll be 1, and I could say years. So instead of getting the total in here, I say years dict equals YR. It's going to be years dict YR. And then I do the same thing here with, oh wait, it's going to be sum I'm just going to copy this line because it'll actually work out better. And say count. Okay, so what's going to happen is it's going to, every time it encounters a new record, it's going to get the value of 1970. Like if YR equals 1970, that this is going to find the sum that's in 1970's dictionary and add the current magnitude to that value. So then at the only thing I need to change at the end is say, so this is going to be, actually I need another, this is a lot less effective way to do it, I guess. Format, indent, and I need to get, see, if year count, and then Control C, Control C. This needs to be sum. And then this should produce the exact same output. I did that pretty fast. What does this say? Key error 2017. Oh, because it's not actually going to return. Oh, because there are some in 2017, so this needs to be 18. I'm sorry. I forgot that. Remember, it goes through 2017, so range actually returns. Okay. There we go. Huh. Oh, I never did a count equals count plus 1. Oh, that's right. So this just needs to be plus 1. There we go. There we go. Those still don't look right, do they? No, it's like this. What happens when you try to type too fast? Okay, that'll work. So these should be the same numbers. Yeah, those are the same numbers as before. Okay, so I'll leave it up here, and that's equivalent code, but it was a lot more complicated to do it that way. So in other words, the difference. What was the main difference? In the first example, I returned the entire search cursor. Sorry, in the second example, this example, I got all of the data in the search cursor every single year. So my table contained everything. And so what I had to do was find a way to weed through it and say, well, if the year is 1970, add it to the 1970 total. And if the year is 1981, add it to the 1981 table. And if the year is 1983, add it to the 1983 total. See how that's more complicated? That's what I did here. That's what I'm doing. So you don't need to understand, in this case, all the code. But that's what I'm doing. I'm saying I'm creating a bunch of different totals, and I'm adding the totals up to each one, and the counts up for each one. That's really complicated.
Those running totals, so you say.
Yeah, running totals. They're running totals, and at the end, I take care of calculating the means. So in this one, though, instead of keeping track of every year's individual total, I just say, give me all the 1970s data. I calculate the mean for that. And then I say, give me all 1971's data. I calculate the mean for that. That's why this code is more simple and straightforward.
Is that what you call reduced functions too? Are you coming out with, you just coming out with one number?
None of these are functions, but yes, this is this is a reduce operation. We're taking all of the elements and we're returning out a summary of the element. So yes, that is a reduce function. Yep. And later in the course when we discuss a few other modules, we could then take this information and graph it, show the magnitude of tornadoes over time. Now they're not changing that much, but there are. I mean, when you have 339 different records, 2.5 in 1974. That's a lot. That's a lot different. What's the lowest one? 2.24 maybe. I mean, that's probably a significant difference. Okay.
It's going up and down, up and down.
Yeah, sure. The other one?
No, that one.
That one. Yeah. So really, I mean, I'll just leave this in here, but yeah, that's
Wait, no, the other one.
the other one.
Yeah.
Okay.
The crazy one.
The crazy one.
You're gonna save all those different.
Yes, these will all be on the
Okay.
the course website.
I'm saying years are there.
These will be on there. In fact, I could. Do you want me to just put them on there right now?
Sure.
Okay. So close those up. And I've been putting them all right here, but let me put them. Search cursor.py. I don't think I need that. I think that one was one. Copy. M6. Paste. Of. Oh yeah. I hate this. We had that problem before. Remember the I can't hit the button. So GitHub
Doesn't scroll.
it doesn't think your window is going to be this small, I guess. Here. Change that back to 125 for a second. Commit. Whoops. Permission denied. Oh. That's fine. Commit. Nope. Hold on a second. Oh. Oh, maybe I have to close that too. There we go. Push origin. Yeah, if it knows that there's a file open somewhere else, it's not gonna let you upload it. Okay, so now we can go back to here. Just make sure. Yeah, so that should be pushed up there. This was the original one we did before we did it by year. Yep. Okay. So that's the search cursor. All right, now let's talk about the update cursor, because the update cursor will allow us to change the fields. It's basically going to allow us to do a calculate field. And the calculate field, it allows us to do it in a way that we can in a way we can put a whole Python function, so we can have a very complicated change. We can have something that instead of just adding a number or subtracting a number, we can have a complicated way of entering that value. Okay, and so let's change this to update cursor. I'm actually going to change this to file save as update cursor. And the we'll take a look here real quick. But the parameters that you're going to feed an update cursor are very similar to the search cursor. So here you need to give it the in table. You can take all of the fields, or you can just get a list of. You can just give it a list of fields. So if you know that you only want to get the magnitude field, you can get just that. If you want to get the year field, you can get that, and so on. And then you can also enter a where clause. Basically, all the rest of these are the same. I didn't explain what the spatial reference does, but we'll talk about that a little bit more next week when we talk about accessing the geometries. But if you specify a spatial reference, it will return the spatial reference data in a different projection than the data itself is already in. Okay.
Is that because you want the map to maybe represent the whole world, and since you get it from so many different areas, you want to have the appropriate map to show where those tornadoes are taking
Let's say it's
place?
in UTM. You could return it in latitude, longitude. See what I'm saying? Because those the math that does that transformation is inside of ArcGIS. There are other libraries that'll do it, but you'd have to go download those other libraries, install them. But yeah, I mean, I can show that real quick. So if we change this back to star, we update back to star, right? And I'm gonna change. I don't care about this part. I care about this part. What's the magnitude going to be now? Do you guys remember which order that was in? I already closed my window, but what field is the magnitude field?
You got to put 3 down there.
Right here, I'm not even. I'm just going to print the whole thing.
Just the 4th field.
I'm going to print the whole row.
It's the 12th.
Okay. I'm just gonna print it. I'm going to print done down here. And go back to that. Okay. So now I'm going to run this. I'm still trying to answer Elvis's question about the spatial reference. Okay. This will be good because we still we'll cover it eventually. Why isn't this running? Oh, it's not, there we go. It's a quote, not parentheses, I messed up. Okay. So run this. Syntax.
If the I on the if is gone.
Oh. I don't know how that happened, but you're exactly right. Run. Count is not defined. I took count out. So I need to add that back in. Count equals 0. Yep, and now it's back there. Okay. All right, so now it's just going to print every 1,000th record. But now it'll be a little bit easier to see because we can look at just one of these records. So the record starts here and ends here. Okay. So these nones are that new field that we added. Remember that new field? Okay. Do you guys remember what the shape field was? Which field was the shape field in this?
It says polyline ZM. I think.
Yeah, that's what it says. But which order was it?
Oh, like what number it is? Oh, it's second.
It's a second. So what's 0? What's it called? The object ID.
Yeah.
So this is the object ID, and this is the shape field. Okay. Now, does that look like it could be a line? Are there enough coordinates for that to be a line?
Yeah.
Yes.
Yeah.
X and Y, right?
No, it can have 2 coordinates at the point.
Yes, exactly. I have 2 coordinates and it's a point.
Oh, yeah.
I'm going to go read the help and see what I'm getting here. Okay. So the thing about the update cursors is by default, they return this shape at XY. Okay. So this field name, if you want the shape XY, it's going to give you a tuple of the features centroid. So this is a tuple of the features centroid.
That's the center of the line.
Yes. If you want the entire shape, you have to actually just type in shape at as the field. And it's going to give you a geometry object. And that's what we're going to talk about later. Okay? So just so you know, the default is shape XY, and it's returning just the centroid. So that's the center of that line that represents a tornado. If it was a polygon, it's returning the center of a polygon. If it's a point, it's returning what?
XY.
Yeah, the center of a point, is the same point. So that's the only time it's actually giving you the real value. Now, if it's multiple points, in other words, if there's one record that represents multiple points, it's returning the centroid of those multiple points, the weighted center.
So the
okay.
Hawaii example, like the dot, like the central point wouldn't be in each island. It'd be
Whatever
in the middle of those islands.
Yeah.
Okay.
If each dot represented an island. So getting back to Elvis's question, what coordinates do you suppose these are in? And is there a way to find out? We do have to know it, but we can look it up. Where do we look it up? Where do we look up the coordinate system for this?
Wouldn't it be in the property tables of the GIS?
Yes, yeah. Just if we just wanted to find out what it was. Yeah. So we could go back here. We could actually use the describe function to find out what the spatial reference was. But we could also do, we could also just go properties and find out what the, under source, spatial reference, and here it's in USA contiguous Alberts equal area conic. So that coordinate that's showing up there is in that coordinate system. Does it have a WKID? Yeah. So the WKID for that is 102003. Now, most standard projections nowadays have a WKID associated with them. And so, unless you're using your own coordinate system, there's always going to be one of these, and you can just specify the coordinate system that you want the coordinates in using its WKID. It stands for well-known ID, by the way. So basically, it's just there's a government it's actually not a government organization. There's an organization called EPSG that actually stands for something petroleum group. Anyway, they decided to take it upon themselves, and everybody decided, oh, it's okay if they keep keep track of all the coordinate system IDs. So
that's a reference on the WKID system. Every point on the earth has a WKID.
No, every spatial reference.
Spatial reference. So then they know all the references, whatever they specify based on that.
Yep. So spatialreference.org has this. It's 1022003. And this one's actually maintained by ESRI. A lot of them are maintained by EPSG. So that is that's telling you that it's USA Albers equal conic. If I wanted latitude longitude, that's 4326. And that's an EPSG, which most of them are. So that's that petroleum group. I forgot exactly what it stands for, but this is latitude longitude, and it's using, does it say what it is? Yeah, it's using WGS 84 latitude longitude.
Well, you have to put in type in WGS 84, but if you just had 4226, it automatically knows WGS 84.
Yes. So if I want to get these coordinates out in WGS 84, then I have to change my code so that instead of asking, right now I'm not asking for any special coordinate system. I forgot which one that was. Let's go back to the help.
That was in 83. Does it matter?
What's that?
The map projection was in 83.
Well, ArcGIS will do the math to convert. So now the where clause is second. I don't want a where clause, so I just can go no where clause, or I could write none. Either one will work. And then I want the spatial reference. Now the spatial reference, I have to construct a spatial reference because it's not, see, this is a string. It's easy to make a string. This is a Boolean. It's easy to make a Boolean. I have to find out what it wants there, and I can click on it. And it tells me, okay, this is a spatial reference. And how do you create a spatial reference? You can access the PRJ file that's on your system disk. That works. You can use the name of the coordinate system. This is really hard because if you get like one letter off, or you call it equal dash area conic, it won't work. Or you can just specify the WKID number. So what I can do is on the line before this, I could say, hey, I want 4326, and then I'm just going to say SR here. So now this code creates a spatial reference and assigns that spatial reference to this value. And then this says, okay, this is a spatial reference I want to use. So now if I run this, instead of the native coordinates, it actually does the math on the fly, and instead of returning that centroid in US Albers conic, now it's saying, since I'm doing an update cursor, remember I said it would do that? So I got to close this. Because it's trying to, an update cursor says, hey, I want to change the values there. So if it's open in Arc Pro, it says, no, can't open that. But see, now that I ran it, look, now those numbers are totally different, aren't they? See that number? That's the last number that shows up. If I go up here, look at that number. Oh, you can go up. There it is. Right there. See how that number is different? This number is in Albers equal area conic. This number is in WGS84 latitude longitude.
Is there like a filter function where you take something and change it into something else? Is that not good for a map function? We're talking about something.
Well, in this case, I didn't take something and feed it through a function. I just, the function that created this, it's called an update cursor. One of the parameters it asked for was the spatial reference. And so it said, oh, you want the data in 4326, or do you want the data in whatever coordinate system you want it in?
So that would be, so using an update cursor would be how you would find the center point of like any type of polygon or anything like that?
It definitely would work for that purpose.
Okay.
So far we haven't done anything different in an update cursor. Like we could have written search cursor there and it would have run just fine.
Okay.
So I was just trying to answer your question as to what the spatial reference did, and it basically returns the geometry in a different spatial reference than the native geometry is in. So, in fact, if I'm gonna do something here real quick. If I change this to shape at, remember it's going to return the entire geometry now. So now if I run this, that's all I'm going to get is the geometry. And you're going to see that it's going to return at least 2 points. It's going to say polyline object. So here I have to say, I'd have to break the thing up, and that's what we're going to really talk about next week. But it's returning the entire polyline, both points. And so in order to get those points, I have to actually break this apart. We're going to talk about how to break that apart next time we meet. Okay, so the test is next week. So next time we meet is actually in 2 weeks.
I mean, knowing all these tools help you everything into what you actually really want.
Right.
The skills and knowledge to there's so much stuff to remember. You just gotta go to the book and say, give me a module to do this and do that.
Right. Yeah. I mean, you definitely got to tackle the problem. So that's why I'm trying to like give examples of why you might use it. So this is the example for this. Let's say I want to calculate a field value, but the field value is difficult to calculate. In other words, the function isn't just you're adding 5 or you're subtracting 7 or you're dividing by 2. There's some if statements involved. Okay, so that's what we're going to do now. So I'm going to run this one more time just so I can see. Oh, I already ran it one more time. Okay, so what's the last item here? The last item is the magnitude. That's the value you want to calculate. See how it says none right now? If I want to actually put a value in there, I can assign that doing an update cursor. Let me go back to update cursor now. Update cursor. So this is the syntax. I can take a row and assign it a new value just by setting it equal to something. So see how right now I got the magnitude out of it by doing this. Do the opposite by saying row is equal to, in this case, remember it's a I made it a long, right? So 200. Okay. What is that row? We have to calculate that out. 1, 0, 1, 2, 3. That'd be a long thing to do, right?
We use len statement.
Yeah, that's actually a great idea. Len of row minus 1. Why minus 1?
Because that accounts for the start at 0.
Yep. Okay, so this is basically what Elvis is saying is every time through I'm going to take the value 200 and I'm going to assign it to the last item in that row. In other words, in this case, the magnitude field. So now if I run that, I will see that those values get changed. See how it says 200 now? Now,
for all of them.
Yeah, they're all set at 200. Now the problem is that it actually didn't save it to disk. It only did it for our entertainment. The help, if you read the help here real quick, says that you have to actually tell it that you want it to update that row. That's what commits it to disk. So you have to have a line in here that does this. Now, this cursor, we didn't call it cursor. What did we call it? What is the cursor called here? It's the result of this function. Rows. So we say rows.update row, and we give it the row that we just updated. So every time you change the value, you actually only have to do it. Like if you change 5 different values, you still only have to update the row once, but you have to update it. So if you don't enter this, it won't actually change it on disk. I'm gonna just to show you that it didn't do that. I'm gonna open up ArcGIS Pro real quick and show you that in there it still nulls until we run it again the next time. Okay. So I got my tornadoes, and I look at the table and I go over. See how they're all still nulls in there. Okay. If I tried to run the script right now, what would happen?
It'd freak out because it's still open.
Yeah, freak out so it's still open. So I'm gonna close it, and then once I close it, I'm gonna run this, and what it's doing is changing all of those mag fields to 200. So now, if I open up ArcGIS Pro one more time, they should all be 200. Okay, see how those all change to 200? Okay. Okay, so what if I want to change them to a useful value? So remember I said I want magnitude to actually be double. I want it to be double the magnitude if the value is greater than 1. If it's less than 1, I want it to equal 1.
We're going to use a where statement, right? Where it's this, it's
I could do it as a where statement, but in this case, I think it's faster to actually do it as an if statement inside the loop.
Is that like if then? Not if then.
Yeah, it's an if then. I mean, in Python, the then is always understood, but you can still call it an if then statement. So instead of changing it to 200, what I want to do is say, first of all, I want to get magnitude. Do we remember where magnitude was? Can you count up and tell me what it is? By the way, actually, before we even do that, I'm going to comment out all of this. sorry, common out region. So if we say rows dot, oh, sorry, I'm trying to get the describe, because we can get all of the fields. So update cursor.
Oh, yeah, you said 12.
Mm-hmm.
I want to go back to the data access model and describe. Yep. Okay. So I could say I think there's also a separate fields function. Let me see if there is or not. Describe list domains. Nope. Okay. Yeah, so properties such as the data type or the fields. Okay. So I'm going to take this whole thing out. I'm just going to call this table is equal to this, and then just call this table, just write table. I don't have to deal with that anymore. All right. So before that, I could go table, or sorry, arcpy dot da dot describe. I'm doing basically this. So I'm going to describe the table. I gotta call this something, because this is going to return a describe object. I'll just call that desk table. So now I'm asking it to describe the table, and then I want to find out what the fields are. Okay. So I could say feature class properties should be, no, it's under table properties, right? No. So anything that's table will return these table properties. And that'll give me fields. Actually, this will work better than describe, I think. Yeah, let's just do that. So describe could give me a list of fields, but this will work faster. So if I just go table. So right now, when I run this, it's just going to give me a list of all the fields. So that's a list of all the fields. Now it says field object. So if I wanted to get the names, I would actually say, I think it's name. So that'll give me the first one. Yeah, object ID. Okay. So,
if you took away the 0, you would get all of them, like the bracket 0. You get
right.
all the names.
Yep. Or if I went like this. So what I really wanted to do is do this. For field in fields, print field, just so I didn't have to keep opening up ArcGIS. Print field and field, oh sorry, field dot index, because that was one of the properties, and field dot name. So now at the top of my script, when I run this, I'll be able to know which field is which. So object ID is, It does have an attribute index. I saw it. Return value, field, domain is nullable. I thought I saw it. Okay. All right. It's an easy way to solve that, though. Okay, so now it will tell me what the values are. So it'll say object ID is 0, index isn't changing.
Number count, you got like the number 1, 2, 3, 4, 5, 0, 1.
That's what I'm trying to do. I got it almost. My syntax was just wrong. I'm pretty sure Okay, so now I can see that magnitude is the 32nd one.
Oh,
And mag is equal to 11. So the reason I'm doing this, so now I can go undent out this dedent region, or sorry, uncomment region. And the reason I'm doing this is so that now I can get the value of magnitude. Which one was it? Go back in here, it's 11. So magnitude is equal to row 11. So now I have magnitude. And now I can enter my if statement. I can say if mag is less than 1, do something, else do something else. Well, what am I going to do? Well, I'm going to take my value and I'm going to say that it's either 1 or it's mag times 2. See that? So now when it comes in here, it'll find out what magnitude is. If it's 0 or -9, it'll execute this and reassign it a value of 1. If it's greater than 1, it'll double it. So that's the language way of saying what I said before. So now it'll run that, and it'll still print out all the fields first.
What is that number 32 as magnitude again? Is it double it? I thought 32.
Am I printing every single row? Oh no. Sorry, what was that?
I saw the magnitude. The number was 32 in there. Or was that just the length of it?
That's the index.
Oh, index. Okay.
So this is the 32nd. Well, it's actually the 33rd field. So object ID. See here where it starts. Object ID is 0. Shape is 1. FID is 2, and so on.
Okay.
So I know what every single item is.
Oh, okay.
I just wanted to not open up ArcGIS again, so I wrote a little Python script that figured out what each index was. So that's what that is. Okay, so now I am going to open up ArcGIS again and see that it did what I wanted to do. Okay. See how the magnitude is 2? Let's find it. See how it changes everyone's 4, 2. It's double what this one was. So here the magnitude is 1. So it doubles it. If it was 1 or more, it doubled it. So that's why this one's 2. Okay. So it did it.
Is that every time it runs through a row, you just keep doubling like that? Is that what you're
Yeah, so it looked at the value of magnitude, and if it's less than 1, it assigned it to be 1. If it was greater than 1, in other words, yeah, 1 or greater, sorry, then it doubled it. All right, now, the last thing that we're going to do to cover this is I would actually recommend that you write this part right here, this if statement, as a function. And I'll show you why. Okay. So if I want to change this so that it was a function, I would need to return. I would need to send it a value and then return a value. Okay. So I'm going to rewrite this. I'm going to say, I'm just going to change it to be like this. Well, here, I'll say out val is equal to, and I'm going to come up with the name of a function. I'm going to call this magnitude adjust. Okay. And then I'm going to give it the magnitude, and it's going to return the output value. So I'm going to go up here to my top here and create my function. So what should my function be called? I'm calling it right here. So what should it be called? Adjust. Yep. And then it's going to take how many parameters? Just one. It's just going to take that.
Oh, okay.
So mag here. And then it's going to return, well, here, so now I'm going to take this if statement and just put this up here. And I don't need any of this, though this part right here, I can just go out, return 1 or return magnitude times 2. So it's the same logic, but now down here I can get rid of all this. So what it's doing is it's taking the magnitude value into the function and it's applying the same logic, and it's either going to return a value of 1 or a value of 2 based on what it says. Okay. It's going to produce the exact same thing. I'm going to run this. Oh, it's going to fail because acquire lock. So I'm going to run this, and it's going to run that through, and all the values are the same because it's applying the same logic. I just did it as a function. Now the reason that I recommend that you do it this way is that now, recently, ArcGIS, actually, I mean, it's been about 3 years since they added this ability. You can actually write a Python function right into calculate field. If we go to SPA, I mean, if we go to the one I've been working on, and we go to calculate field, we can choose the tornadoes input table, and we can choose what field name we want to update, which is magnitude. And then we can choose an expression, a Python 3 expression, and we can enter a code block. And what you enter there in the code block is you enter this function. So if you've entered the function right, you can just copy and paste that right in there. So now I have a function. And then here you are inside the rows, and so you need to call the function. So how do I call the function? Magnitude is equal to, how do I call the function there? Mag adjust.
And with parentheses, not
right. And then how do I get the value of the magnitude field? Well, you've done this before, but I can cheat and just go, not the magnitude field, the mag field. I can cheat and just go up here and double click mag. See, I cheated, and now I go back down here and look, that's how I get it. So what's going to happen is that when I press run, it actually is creating a search cursor in the background of all your data, and it's feeding them into this function you just created. You created that function because it's right here. So when magnitude is equal to 1, it's going to feed it into this function. 1's going to go into here, and it's not going to do this one, it's going to do that one. It's going to return magnitude times 2. Next time, if magnitude equals 0, it's going to go in here and say 0 is greater than 1 and return that. And so on. So now if I run this, it's going to have the same effect, but it's going to work. So the point here is, one of the reasons for writing a Python script is if you have a very complicated transformation in a calculate field. But if it's a one-off, you could do it right in ArcGIS Pro. However, the point still stands. If this is something that you're going to do like over and over and over again as part of a script, you write it in a script, but you make it a function so that it's easy to pull out of your code if you ever want to use it in ArcGIS Pro.
So can you change like the name of the field? Like if you wanted to change, actually no, I'm taking it back. Like if you have like a number, and like kind of like the census did, how like it's like a 10-digit number, but each thing means something else. Like can you take away and only leave one?
Yeah, that's a good question. So I think, like if I open my attribute table here and looked at this data, you're talking about I don't know, yours probably looks different, but you might have a FIPS code. See how I have this long code, the AFFGOID?
Yeah.
I might want to get just, like I already have the GOID, but what if I didn't have that,
Yeah.
right? So, yeah, I could write a Python function that would just return the last 4 characters in there, and then I could calculate it into a new field. I could do that here in the geoprocessing window, or I could do it in the script tool. So if I do it in the geoprocessing window, obviously I change this to US counties. And I probably want to add a new field to do this.
Yeah.
Let's say that the GOID really didn't include this first number. See how it says US is 0? I just wanted to get the last 4 digits. So let's recalculate GOID just to get the last 4 digits instead of the last 5 digits. Well, I could change this from, I could change this GOID. So in our scenario, somebody did it wrong, and we need to get that. So now I'm just going to say, I'll just call this get last 4. And in my code block, I can write my function. It's not going to be magnitude anymore. It's going to be AFFGOID. And then this will be I don't have to call it the same thing. That's just what I'm going to refer to it in there. So now I could say return long string, and I want to get the last 4 characters. So remember Python, I could say, okay, I want to go to the end. So I need to figure out where to start. So that's the length of long string minus 4 or 5. We'll try 4, and then if it doesn't work out, then we'll do 5. So it's going to return the long string, and it's going to take the length of long string minus 4 and go all the way to the end. I messed up. I didn't spell long string right sometime. Long string. There we go. So yeah. So there it goes. So see how it used to be 0, 4, now it's getting not those. Or alternatively, you can actually have it build a string based on several other strings. So sometimes you might have a scenario where you might want to do a dissolve, but none of your fields are completely unique. You've got a state field and like a county ID field, and there's a county 1 in New Mexico, and there's a county 1 in Arizona, and a county 1 somewhere else. So you might want to concatenate those two fields. So you can write the Python script to do that. Now that you could actually do without a function. Okay? But this or the first example would be harder. Okay. All right. So for today's assignment, I'll go ahead and type it back up. But for today's assignment, you're going to take this script and you're going to modify the script. And instead of recalculating them, you're going to add another field called month. Okay? You add a new field called month. And you can actually do that in the script, but you don't have to do that in the script. So you're going to add a new field called month, and you're going to make that field a string. Okay? So your new field is going to be a string. And I want you to write a script that will take, what's going to happen is what's going to do is if it sees a 1, your script should change a 1 into January in the month field. And if it's 2, yours should change 2 into February, and so on.
Just to change the MO field?
Yes. So the MO field is going to be changed from a numeric, well, not changed. It's going to stay the same, but you're going to create a new field, and that new field is going to get the value of the month, but as a name, as a named month. Okay. Anybody have any questions about that?
Yeah, rather than saying 1, 2, 3, 4, 5, you put an actual name there.
Yep. So you're going to have a new field, and it's going to have. So you're going to write it. You're basically going to have a different if-then statement here. Okay, and you're going to be feeding it a different month instead of, a different field here. You're not going to be feeding it the magnitude. You're going to be feeding it the month field. So you have to figure it out. Now it's fine with me if you don't want to get all the fields, like this one is getting all of the fields. So here we're getting all the fields. You really only need to get the month field and the new month field. So the MO field and the month field that you create, those are the only fields you really need. But if you did that, they'll be indexed 0 and 1, right? Instead of being indexed whatever month is.
13 or whatever.
Yeah.
So do you want this created in like this platform or like a Jupyter notebook? Or do you want us to put it actually into our map and then like map it?
Yeah, so for this assignment, you can do it either in IDLE, which I think would be the easiest, or you could do it in Jupyter. Well, I think this assignment might be easier to do it in IDLE. You could even do it here, but it's going to be a pain to like enter everything in the code window. So I would actually do it in IDLE or Jupyter.
Because what I was doing is that I would write it in IDLE, but because my location never works right because I guess I'm doing it wrong. So I just do it and then I just paste it back into Arc and then run it.
Okay. Well, we can try to see why it's having a problem, but this should. There's nothing in here that you can't do in a Jupyter notebook. Like, I'm gonna open up Jupyter notebooks, and I should be able to just create a new Python 3 and run this. And it's not going to do much. It's just going to say done at the bottom. Yeah, so it finished. So it ran just fine in Jupyter Notebooks. So you could run it in Jupyter Notebooks as well. There's no reason not to. I think a longer script like this, I wouldn't do it. Jupyter Notebooks is going to become a little bit. I mean, it's for doing interactive work. And so if you actually want to like print a graph at the bottom, then Jupyter Notebooks works great for that. Okay. So here, this particular script is more like a script where you would be ingesting data and modifying it, you know. And so there's no real significant interactive output to show. You're just showing results. So that's why I would do this in IDLE. But you guys didn't have IDLE until this week. So that's why I did some of these types of scripts where they don't produce anything interesting in Python. But, like, okay, remember we did this though a few weeks back. So, oops, that's not what I meant to do. Open courses. I showed you this. SPA. Was it week 4, I think? Yeah. So see how when I run this example, I'm creating a chart. So that's why that might be something that's kind of neat to do in. This looks bad on my small window, but it looks great above. So I'm creating this chart. Well, if I did the early example with the tornado intensity, I could have created bar charts of the tornado intensity and put them on the thing by year. So it might be interesting to see. Probably want a bar chart this way, maybe see how they change, or maybe even just a line chart.
You can also do how many per month.
Yeah, you can put both of those lines on the same chart. So yeah, we'll get there. We'll start talking about plotting here. We just got a few more concepts that we need to cover. So basically, we're going to cover the how to access the geometry itself, and then we'll cover using pandas to do some data analysis and matplotlib to show the analysis. That's what I'm using here. It's matplotlib. Okay. All right. I'm going to I think we should take our break right now. I've already actually explained what you're going to do for the assignment. So I'm not going to do that in the lab. In the lab today, I'm going to talk about NumPy and one more attribute of the data access module, and that is the ability to turn all of this stuff into other data types that can be manipulated outside of ArcGIS. Okay. So what time is it? 3:14. Okay, yeah, let's take a 15-minute break. Come back at 3:30, and then there'll be about a half an hour of talking about NumPy.